video is over compositions of transformations. This is what happens when you do more than one transformation at a time to a figure. We're on page 163 of our INB, and the second page will go on page 164. As you can see here, I already have my first figure plotted at A of 1, 2, B of 3, 5, and C of 5, 1. So the first thing it asks me to do is it says I'm going to reflect the triangle over the y-axis. We should know by now that in our coordinate notation, if I'm reflecting over the y-axis, that that's going to actually affect my x-coordinate. So a y-axis is going to look like the x, y, and then the x is going to become opposite. So it needs to be the same distance away on this y-axis line. So here would be A prime. B prime is 1, 2, 3, 1, 2, 3. And C prime is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here is C prime. And you can notice that they are the same distance away from the y-axis on both figures. If I were to do it just based off my coordinate notation, then my x-coordinates are going to become opposite of the original. So this will be opposite 1, which is negative 1, 2, negative 3, 5, negative 5, 1. Okay. The second thing I want to do is I want to now reflect it over the x-axis. So let's change my color here. So I'm going to reflect it over the x-axis. When I do that, it actually affects my y. Now we're going to do it from my red figure here. So my green figure is going to be based off my red. It's going to be reflecting over the x, so it's down negative 2. So that'll be A, and we're going to call this one double prime so we know which image we're talking about. C double prime will be 2 away, and B double prime will be 5 away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's B double prime. We're going to connect these points here. Okay, so this time I have negative 1, negative 2, negative 3, and then negative 5, negative 5, and negative 1. So let's look at our coordinate notation here between the blue figure and the green figure, our pre-image and our double prime image. So between x, y, our first figure translated, or excuse me, in this case it reflected. What happened to our x-coordinates? Well, if I look here at the 1, 1 changed into negative 1, so that would be an opposite x. 2 changed to negative 2, so that would be opposite 2, or opposite y, excuse me. So our coordinate notation is opposite x, opposite y. We should be able to recall that when I have an opposite x and opposite y, the transformation of that is similar to is a rotation that is 180 degrees. Okay, so if I reflect over the y and then the x, it is the same thing as a rotation of 180 degrees. Let's look at our next example. So here I've got my new figure drawn for me. Let's connect my points. Okay, and so this time we are going to do a reflection of the triangle over 2 parallel lines. So previously we've been doing it over the x or the y-axis, but now we're going to do it over x is equal to 3. So what I'm going to do is I'm going to take my ruler, or as line, and I'm going to draw a straight line where x is equal to 3. So 1, 2, 3, here's x is equal to 3. I'm going to draw a straight line all the way down. Let's see if we can move that over just a bit. There we go. It's more on the actual line. So now I want my points to be the same distance away from this line here. So this would be D prime. It's 1 away, both on that line. E prime is going to be 2 away. 1, 2. And F prime is 1, 2, 3, 4 away. Connect our points. And let's write our new points. Our new points are going to be at 1, 2, up 1, E is 1, 5, and F is at negative 1, 3. Okay, so now we're going to do the same thing, except for now we're going to reflect over x is equal to negative 2. So let's take our ruler again and draw me a straight line at x is equal to negative 2. It's pretty good there. So I want these points to be the same distance away from this green line now. Okay, so F prime is 1 point away, so F double prime is going to be 1 point away. E is 1, 2, 3, 1, 2, 3. And D is 1, 2, 3, 4, 1, 2, 3, 4. Let's connect those points. Okay, so let's look at what happened here. So our new points are at 1, 2, 3, up negative 3. E, D is at 1, 2, 3, 4, 5, 6. And E, B, negative 5, 5. So let's look at between our D, 4, and D, and negative 6. What did I do to 4 to get to negative 6? Well, I subtracted 10. What did I do to the y's? Well, all the y's just stayed the same. Okay, so we can see that this is similar to doing a translation of 10 units to the left. Translation of 10 units to the left. Notice that our figure looks in the same exact position as it did here on the pre-image and now on the double prime image. So they're in the same exact points. They've just been shifted over 10 units to the left. Let's look at our next figure. Here I've got my figure GHJ. The first thing I'm going to do is I'm going to rotate the triangle twice, and I'm going to rotate it first around the origin 90 degrees counterclockwise. When I'm going counterclockwise, I'm going to switch my y's, my y and my x, so my y and my x, and then my y is going to become negative, or opposite. So I'm going to write my coordinates first this time. So I'm going to switch the 2's, and then my y becomes opposite. 0, 4, opposite of 0 is 0. 6, 5, opposite of 6 is negative 6. So let's plot those new points now. So here's G prime, H prime, and J prime. And we can connect those points. And there's our new figure. Okay, so the next thing we're going to do is we're going to rotate it again, but this time we are going to rotate around that point of negative 2, 2. So what that means is that that point is not going to change. Okay, so I'm going to show you where H is going to become. It's going to move down here to that origin, so that's H double prime. And J is going to be here. So let's connect those points.